In this video, we'll learn how to solve an apportionment problem using Webster's method. Here's a typical problem. Suppose a nation has 4 states with populations shown below, and a representative body with 60 seats. How many seats should each state get? At this point, if you haven't watched the introduction video, you should click on the link below and watch that now. As we learned in that video, we figure out the fair shares for each state using the standard divisor. The standard divisor is the total population of the entire country divided by the number of seats. In this case, that turned out to be 3460. So then we divided the population of each state by 3460, and that gave us the fair share. The fair shares tell us how many seats each state should get. But the problem is that those aren't whole numbers. So we need the number of seats we assign to each state to be a whole number. How do we resolve this issue? Well, Webster's method gives us a way to do that. Webster's method tells us to round all of the shares to the nearest whole number. Now, it might be that that gives us the correct number of seats. If we take those rounded shares and add them up, we might get the number of seats that we're looking for, in which case we're done. If not, then we've got some more work to do. We'll need to modify the standard divisor by making it larger or smaller until the rounded shares add up to the correct total. So let's see how this problem works out. We'll take those fair shares and round them. So the fair share for A was 21.47. That gets rounded down to 21. 18.38 gets rounded down to 18. 12.24 gets rounded down to 12, but 7.91 gets rounded up to 8. But if we add up all those rounded shares, we get 59 seats, which is not the number that we're looking for. Since that's not enough seats, that means our shares are too low. We can make them bigger by making our divisor smaller. If we divide by a smaller number, we'll get bigger answers. Since we want our shares to be bigger, we'll want to divide by a smaller number. So we're going to modify our divisor by making it smaller than what it is right now. So we'll want a modified divisor that's something less than 3460. So let's try 3400. We're pretty close. We're at 59 seats, so maybe we should try to just make it a little bit less. So we'll get our modified shares by taking our population of state A and dividing it by 3400. That gives us 21.85. And then the rounded share will be 22. That gets rounded up. We'll do the same thing for B, C, and D. B's modified share is 18.71. That gets rounded up. C's modified share is 12.46, that gets rounded down, and D's modified share is 8.05, that also gets rounded down. But that gives us 61 seats. That's too many. That means our shares are too high, so we can make them smaller by making the divisor larger. If we divide by a larger number, we get smaller answers. But we already know that 3460 is too big, and 3400 is too small, so we know we're looking for a number that's somewhere in between 3400 and 3460. Let's try 3440. Again, we'll take a population of state A divided by that new divisor. That gives us 21.59, which gets rounded up to 22. Do that for all of the states, and when we do that and round the shares and add them up, we get the 60 seats that we're looking for. So the thing to keep in mind for Webster's method is that if the total number of seats is too high, you need to make the divisor larger to make the shares smaller. If the total number of seats you have is too low, you need to make the divisor lower to make the shares larger. So that's Webster's method.